Hi fellas, this is Chemaddcts again to the solution. Welcome back to another video tutorial. Well fellas, today we're gonna study unit 2 of chemistry. Okay, that is the core principle of chemistry. So fellas, by this question you may guess that what will be the solution for the problem. What would be the problem for the solution? Okay, what would be the problem for today that we're gonna solve today? So that is Born-Haber cycle. Okay, so we're gonna study a question related to Born-Haber cycle. Okay, so at first let us read the question. The question says Born-Haber cycles can be used to determine experimental values of lattice energies. The diagram below shows a Born-Haber cycle for the formation of strontium chloride from strontium and chlorine. So here we will here the Born-Haber cycle is given for the reaction between strontium and chlorine. Okay, so the Born-Haber cycle is for the reaction between strontium and chlorine. Okay, so this is the Born-Haber cycle for the reaction of strontium and chlorine. Okay, so before going to the question, let us recall some of the definition that we have learned earlier. Okay, so here are some of the definitions that we need to know in order to solve this question. uh, at first let us know what is meant by enthalpy change of formation. Okay? So enthalpy change of formation is the energy change. It is the energy change when one mole of substance is formed by the required amount of elements reactants in the given equation. Okay. So enthalpy change of formation occurs when one mole of substance is formed by the required amount of elements, that is the reactants in the given equation. Okay. Here in here let us recall the enthalpy change of atomization. Okay, enthalpy change of atomization, it is the energy required when one mole of gaseous atoms are formed by the required amount of elements reactants in the given equation. Okay, so enthalpy change of atomization is simply the energy required, okay, when one mole of gaseous atoms are formed by the required amount of elements in the given equation. So here the one condition for being atomized, okay, is for the atoms should be the atoms that will form is gaseous. Okay, so the gaseous atoms are formed here. Okay, so the phase for these atoms are in gaseous. So this is the important thing, and it is the energy required. Since we are breaking the bond, so this will be the energy required. Okay, so now let us look at first ionization energy. It is the energy required to remove one electron from each of one mole of gaseous atoms to form one mole of unipositively charged gaseous ions. So what is meant by unipositively charged gaseous ions? That is um, positive charge, plus one charge. Okay, charge, not charge, charge. So now let us look back at the second ionization energy. So it is the energy required to remove one electron from each of one mole of unipositively charged gaseous ions to form one mole of dipositively charged gaseous ions. Okay. So now let us recall what is made by first electron affinity. So first electron affinity is it is the energy released when an electron is added to each of one mole of gaseous atoms to form one mole of uninegatively charged gaseous ions. Okay, so this is it. It is the energy released when an electron is added to each of one mole of gaseous atoms to form one mole of uninegatively charged gaseous ions. And for the last, okay, so for the last thing that we will come across here is lattice energy. It is the energy released. Okay, be careful about this. It is the energy released when one mole of ionic solid is formed from the required amount of gaseous ions. Okay. So that's all the definition we will need for solving this question. Okay. So let us get back to the question. Here, at first, let us identify the enthalpy changes that are occurring in this reaction, that are occurring in this Born-Haber cycle. Okay. So at first, let us identify the enthalpies. So in here, what is meant by del H1? Let us see. So here we can see that these are the reactants. Okay. So this arrow sign means that this thing has reacted to form this thing. Okay, so these two are reacting. Okay, and this direction means that these two are reacting, and this thing is formed as the result. As a result, this thing has formed. So these two are reacting and forming this thing. So this is formation enthalpy, as we can see. So formation enthalpy. Okay. So again, let us recall the definition. So enthalpy change of formation. It is the energy change when one mole of substance is formed by the required amount of elements reactants in the given equation. Okay. So here it is the energy change. So why we are calling this as energy change? Because this might be exothermic or endothermic. We are not sure. So that is why we are saying that it is the energy change when the required amount of elements, okay, it is the energy change when the required amount of elements or reactants react together to form 1 mole of products. Okay, 1 mole of compound substances. So here as we can see that here 1 mole of substance is formed. So this is called formation enthalpy. Okay. Now let us look at this thing. What is meant by del H2? So in here, let us see here. As we can see that this is strontium in solid state, and this is fluorine, Cl2 gas, fluorine gas. Cl2 means chlorine gas in gaseous state. So this is element and this is also element. So now let us look at this thing. So in here, strontium is in gaseous state. Fluorine is also in gaseous state, but there it is in molecule form. So by this thing we can be assured that these haven't been broken. The bonds haven't been broken in fluorine. The only bonds that are being broken here is element. The only element that is been broken here is strontium. Here we can see that strontium has changed its phase from solid to gaseous. So here the strontium is atomized. Sr is atomized here. Okay, since strontium is been atomized, so this should be the enthalpy change of atomization of strontium. Okay, so this is enthalpy. Let me write this in another way. Del H atomization of strontium. Since the strontium has changed its state from solid to gaseous, since we all know that strontium is a metal and it can't be in gaseous state in the nature, so the strontium is solid in nature, so it has changed its phase from solid to gas, and by this thing we can be sure that here only strontium is been atomized, not the chlorine. Okay, here we can see that the chlorine bonds aren't being broken here. So that's how it is. Okay, so let us look at the definition once again. It is the energy required when 1 mole of gaseous atoms are formed by the required amount of elements in the given equation. So here 1 mole of gaseous strontium atoms are formed by the required amount of strontium solid substance. Okay, so that is why this stage, this H2 is uh, at enthalpy of atomization of strontium, not fluorine. Okay, so that is how we gonna say. So let us move on to del H3. So what is del H3? Let us see. So if we compare this with this, okay, so the chlorine is unchanged over here. The only change have been here is strontium. So the gaseous atom strontium here is ionized. So how can we be sure that, how can we be sure that here strontium is been ionized? That's because strontium has lost one electron over here. So this is first ionization of strontium. Okay, so this is the first ionization of strontium. Okay, so del H3 is the first ionization of strontium. Okay, now let us have a look for del H4. So in here we can see that this strontium has been changed, but the chlorine is been unchanged over here. So in here the strontium has again lost another electron to form Sr2 plus. So this should be definitely the second ionization energy of Sr plus, not Sr, sorry, Sr, strontium, not Sr plus. So we are ionizing for the second time. We are second time ionizing the strontium over here. So this should be the second ionization energy of strontium. So del H4 is the second ionization energy for strontium. Okay. So let us have a look for this thing. What is meant by del H5? Here, as we can see that this chlorine bond has been broken over here, and this thing is unchanged. Okay, so this whole thing is been unchanged over here. This stays as Sr2 plus and 2 electron, and in here Sr2 plus and 2 electrons. So this part of this equation is unchanged, so we will leave it like that. So if we look at this thing, this part, so we can see that here the bonds of chlorine molecules have been broken. So in here we can see that here atomization of chlorine occurs. Okay, so atomization of chlorine gas. So in here the atomization of chlorine gas is happened. So del H5 would be the atomization of chlorine gas. Now let us have a look for del H6. So in here, as we can see that these chlorine gaseous atoms have gained 2 electrons to form 2 Cl minus. So here is one thing that we need to understand, that here each chlorine atom received 1 electron. Okay, so this should be first electron affinity, not second electron affinity. That's because here each chlorine atom has received each electron to form uninegatively charged chloride ions. Okay, so fellas, don't make mistake over here. Most of the students might make mistake over here. So this should be not confused with the second ionization energy. Okay, so some of the student might write this as first electron affinity plus second electron affinity, but no, this should be first electron affinity of chlorine gas. Okay, so to chlorine. So why this should be only first electron affinity of chlorine? That's because here the chlorine atoms, as we go according to the definition of first electron affinity, okay, so it is the energy released when an electron is added to each of 1 mole of gaseous atoms, 1 mole of gaseous atoms. Okay, in here we have chlorine gaseous atoms to form 1 mole of uninegatively charged gaseous ions. Here 1 mole of uninegatively charged gaseous chloride ions is formed. Okay, so let us match this thing with the definition. So in here uh, in the definition we have 1 mole, and in here we have 2 moles of chlorine. So 2 moles of chlorine gaseous chlorine atoms, 2 moles of chlorine gaseous chlorine atoms has received 2 electrons to form 2 moles of uninegatively charged gaseous chloroatoms. So that is why this should be the first electron affinity of fluorine. Just simply that here uh, Cl minus is formed, not Cl2 minus is formed. So that is why this should be first electron affinity, not second electron affinity. Okay, and we all know that first electron affinity releases energy. So first electron affinity should be endothermic. Why? That's because here the electrons are being attracted in since this is not charged particle, this thing is not a charged particle, so this will attract negative electrons towards it, and we all know that attraction always make bonds. So here bonds have been made. Since the bond has been made over here, so this should be endothermic reaction, not exothermic. Okay, so that is why the arrow is downward. So I hope that why this should be the endothermic reaction. Okay, why the energy is required over why the energy is released. Sorry, I'm really sorry for that. So why the energy is released over here? According to the definition, it is the energy released when 1 mole of gaseous atoms receive 1 electron to form 1 mole of gaseous uninegatively charged ions. Okay, so that is why the energy is released over here, since it is attracting electrons, and we all know that attracting electrons always results in energy release. Okay, and finally this should be the lattice energy. Okay, so according to the definition here, it is the energy released when it is the energy released. So let us review the definition. It is the energy released when 1 mole of ionic solid. It is the energy released when 1 mole of ionic solid uh, is formed. 1 mole of ionic solid is formed. It is the energy released when 1 mole of ionic solid is formed from the required amount of gaseous ions. As we can see that according to the definition, that here 1 mole of solid ion is formed from the required amount of gaseous ions. So this should be the lattice energy. So del H7 should be the lattice energy. Now let us answer the question. Using symbols from del H1 to del H7 as appropriate, identify the enthalpy change of atomization of strontium. Okay. So atomization. So this should be del H2. Okay. So this step should be atomization del H2. Okay. So here in del H2, this in del H2, strontium has been atomized. Okay, so that is why this should be the answer should be del H2. Okay, now let us answer this thing. The bond enthalpy of chlorine. Okay, so the bond enthalpy of chlorine. What does the bond enthalpy means? Bond enthalpy simply means the bonds are broken. So the energy required to break the bonds is called the bond enthalpy. So let us see where the bonds are broken in chlorine. So in del H5, since the chlorine chlorine molecules has been broken down into chlorine atoms, gaseous chlorine molecules, since the gaseous chlorine molecules has been broken down into gaseous chlorine atoms over here, so this should be the bond enthalpy thing. Okay, so this del H value should be bond enthalpy. Okay, so this should be del H5. Simply let us put it in simple way that in this step chlorine bonds have been bond over chlorine bonds have been broken over here. Here it is chlorine molecule, in here it is chlorine atoms. So chlorine molecules are broken down into chlorine atoms. So this should be bond enthalpy. Okay. So now let us move on to first electron affinity. Okay. So the answer would be the answer for 2 is del H5. Okay. Let me write it clearly. Del H5. Okay. Now moving on to 3, first electron affinity of chlorine. So what is the first electron affinity of chlorine? So in here, the first electron affinity of chlorine is 6, del H6. Okay, that's it. First electron affinity is del H6. Enthalpy change of formation of strontium. Oh, this thing. This this is the formation enthalpy of strontium chloride, which is del H1. Okay, so del H1 would be the formation enthalpy. So fellas, I hope that you have understood the question as well as the solution. Sorry for making this tutorial longer. Okay, pretty longer. That's because we have discussed in details about this problem, so that the so that we have in order to revise the whole chapter, we have solved this question, and we have made a revision of this topic. So we have made a revision over here, so that's why the video is pretty lengthy, and we have discussed in details about this topic by solving this question. So once again fellas, sorry for making this video longer, and if you have any question regarding this topic, please feel free to ask question in the comment section, and I will be always there to help you out. Okay fellas, so that's it for today. So signing out fellas. Best of luck for your exam, and peace with chemistry.